This question, word problem, sum of one positive number and the square of another equals 15. Choose the numbers so that their product is as large as possible. Enter the exact value of the product of the two numbers. Interesting. Okay. So the sum, the adding up, so I'm going to let x is the first positive number, and I'll let y be the second positive number, right? We're talking about two positive numbers. And then it says, so we have two equations. It says the sum, so that means the adding up of one positive number and the square of the other, so y squared equals 15. And then they say, choose a number so that their product is as large as possible. In other words, we want to maximize their product. So it means by as large as possible, right? Max. So what is their product? Product means multiply. Multiply them. So I want to maximize x times y. Okay. So here's where I want to help you because you have all these equations, it can be very confusing. Here's how you want to think about it. You always want to mainly focus on, so we have two equations. We have this one, and I'm going to call this guy the helper. Okay. And then this one here is the one we're trying to maximize. It's not equal. Notice it's just we want to maximize this. So we have one, I should say formula, not equation. One formula we're trying to maximize and another equation that they give us. So how's that work? So basically the game plan is to make the max or the min or whatever have only oops, one letter. That's the trick. We don't want two letters. So how are you going to do that? Well, you can use the helper. You're going to use the helper and plug in. Let me show you right here. Use the helper and solve for one letter. Plug into the max. That's what we do. So come up here, we're going to use the helper. Like I could solve for x. I could bump this to the other side and say, okay, so x is 15 minus y squared. Then I can grab that and plug in for x. So now I'm maximizing x, which I now know is 15 minus y squared, times y. I'm trying to maximize that. Now it's only got one letter. See what I did there? You let the helper help you to make the one you're trying to maximize or minimize have only one letter. That's what we always do when they give us these two formulas. The first one is the helper, it's an equation. And the main attraction is the thing you're trying to maximize or minimize. In this case, it's maximize. They said maximize the product, which means multiply them, x times y. This is x, so the helper told us, times y. So that's what we're trying to maximize. So how do we maximize that? Let's just call it P for product. It's the product, right? How do you maximize something? You take the derivative of it. So I'm going to take the derivative. Well, first I gotta let me clean this up. It's not really ready for the derivative. I want to maximize. I'm going to distribute this. 15y minus y cubed. Now we're ready for the derivative. The derivative, this is the first power, come on down. 15, subtract 1, so that's gone. Minus 3 comes down. Y squared, subtract 1, right? And then set it equal to 0. That's how we maximize anything. We take its derivative and set it equal to 0 and solve. Okay, now how am I going to solve this? I'm going to jump this guy to the other side. So 15 will equal positive 3y squared, and then divide by 3. Boom. Y squared is 5. Root it. Y is the root of 5. Now, we're not done because they didn't ask for y. They said the maximum value of the product. Well, what's the product? Right here. The product, P stands for product, right, is this. So the product, let's write this. Product, the max product is I'll go with the same color. 15. Well, here, let's just, it is right here. I'll do this version. 15y. You could do either one. You could use this or this. It doesn't matter. Okay, so now I'm going to take that y value we got and I'm going to plug in there and plug in there. So I get 15. Here, let me go with the right colors. 15. And I'm going to plug in square root of 5, square root of 5 for y. And that'll give me the max product. So let's go to Desmos. So 15 root 5 minus root 5 cubed. 15 root 5 minus root 5 cubed. 15 root 5 minus root 5 cubed. 22.36. 15 root 5 minus root 5 cubed. 15 root 5 minus root 5 cubed. Oh, they gave the answer is 10 root 5. Yeah, okay, I'll do it that way. So either way, it doesn't matter here. I'll show it that way. 15 root 5. You could do a decimal. Root 5 cubed means root, I'm getting a little sloppy here. Means root 5, root 5, root 5. Well, what's that? Well, root 5, oop, root 5 is root 25. It's plain 5. Then we subtract those. 15 roots of 5 minus 5 roots of 5 is 10 roots of 5. You can give it that way or you can give the decimal. It's good either way. So what do we do? Let me run over this again. So when they give you two formulas, one of them is what you want to maximize. And how do you know? They'll say that. They'll say, make the product as large as possible. That's maximizing talk, right? So the maximize the product, which is x times y. And the other one is the helper. And now, at first, the one you're trying to maximize has two letters. You don't want two letters, so you got to make it one letter. So you grab the helper, solve for one of the letters, and plug in, making the one you're trying to maximize now only have one letter. Multiply it out, and then maximize it. How do you maximize it? You take the derivative and set it equal to 0. Solve for y. We got it. Then plug back in to the maximum product formula. And we simplified it. And there we go.